Okay, this is Unit 3 notes, basic quadratic function attributes and transformations. So first we're going to talk about the quadratic parent function. The parent function for quadratics is y is equal to x squared. The vertex is at the origin, so 0, 0. The axis of symmetry is x equals 0. X and y intercepts are also both at the origin. The domain is always going to be negative infinity to positive infinity unless there's any restrictions. And then our range is going to be bracket 0 to positive infinity since the parent function points up. So looking at our table, I'm just going to pick some random x values. I'm going to pick some negatives and then some positives. So I have -3, -2, -1, 0, 1, 2, 3. Then I'm going to use the parent function to find my y values. So my parent function is x squared, so I'm going to square each of my x values. So for example, -3 squared gives me +9. -2 squared gives me +4. And then so on and so forth, filling in the rest of the table. I'm then going to take these points and plot them on the graph. So I have -3, 9, -2, 4, -1, 1, 0, 0, which is my vertex, 1, 1, 2, 4, and 3, 9. Okay. And then when I connect all these to form my equation, it's very important that at the vertex area that you are making a U shape and not a V shape. There's two different forms that we're going to see with quadratic functions. One is the standard form. Standard form is going to be helpful when we start factoring. And then vertex form is helpful when we are graphing and writing quadratic equations. Just like on absolute value, we have our HK, which is our vertex. So let's look at example 1. Example 1 says determine the following attributes for the quadratic function shown in the graph below. So first we have to find the vertex. So in this case, it's the maximum of the quadratic. So up here at -3, 4. The axis of symmetry is always the x value of the vertex. So x equals -3. We have two x-intercepts, one at -1 and one at -5. So I have -1, 0 and -5, 0. I have one y-intercept at -5, so I write that as 0, -5. My domain is always going to be negative infinity to infinity. And my range, since this is pointing down, I'm going to start with negative infinity, and I'm going to go up to the y value of my vertex, so that's 4. We're going to do the same thing with number 2. Okay, so number 2, we first need to find the vertex. So the vertex is right here at 2, 1. Since we have the vertex, we can find the AOS, the axis of symmetry, so x equals 2. Notice that my graph here does not cross the x-axis. Since it does not cross it, that means we don't have any x-intercepts. I'm going to write none. And then our y-intercept is right here at 3, so we would write 0, 3. Again, our domain stays the same at negative infinity, positive infinity. And since our graph is pointing up this time, we are going to start with the y value of our vertex, so bracket 1, and then go up to positive infinity. Let's look at example 3. Example 3, notice how our equation is in the vertex form. which means we can look at this and find our h comma k, our vertex. Okay, so right here and right here. Remember, we always choose the opposite of this value. So instead of -4, it's +4. So I have 4 comma -9. This is my vertex. My AOS is x equals 4. And in order to find my y-intercepts, I need to plug in 0 for x. So I have y is equal to -1/2, 0 minus 4 squared minus 9. This reduces to -1/2. -4 squared is 16 minus 9. And I get y is equal to -8 minus 9, which is -17. So I have the point 0, -17. My domain is always -infinity to +infinity. And my range, I first have to look at the a value of this function. The a value of this function is negative, so this tells me that this is going to point down because of that negative. So since it's pointing down, I'm going to start with my -infinity and then use the y value for my vertex, -9, to finish off the range. Okay. Now I'm going to do a quick sketch of this graph. I really only need 2 points here. I need my vertex point and my y-intercept. So my vertex point is at 4, -9, and my y-intercept is at 0, -17. Okay, so I have a point here and a point here. So if I was to draw this, it would look something like this. And make sure we are curving a U shape at the vertex, not a V shape. Number 4. So notice in number 4, instead of vertex form, we are now in standard form. Remember, in standard form, we can't simply find the vertex by looking at the equation. So we are going to use the vertex formula. And that vertex formula is -b over 2a. And whatever number we find here, this is our h value. Once we find our h value, we're going to plug it back into the function. So the function of our h value, and this is going to give us our k value. Okay, so let's go ahead and start that. So -b, we can label this A, B, C. Our A is -2, our B is -8, and our C is -3. For the formula, we need -b. Well, b is already negative, so negative times a negative is a positive. -b over 2a gives us +8 over 2 times, and a is -2. So 8 divided by 2 times -2 is the same as saying 8 divided by -4, which is -2. So our -2 is our h value. Now we're going to plug in -2 back into our function to find our k value. So I have -2 times -2 squared minus 8 times -2 minus 3. This is -2 times 4 plus 16 minus 3. -8 plus 16 minus 3. 8 minus 3, this gives me 5. This is my k value. So that means my vertex is -2, 5. My axis of symmetry is x equals -2. And for my y-intercept, I need to plug in 0 in for x. So y is equal to -2 times 0 squared minus 8 times 0 minus 3. Notice that the first 2 terms cancel out because they're being multiplied by 0. So I'm left with y is equal to -3. So my y-intercept is 0, -3. My domain is always -infinity to +infinity. And my range, I have to look at my a value. My a value is a -2, which tells me it's going down. So I'm going to start with -infinity, and I'm going to end with the y value of my vertex, so 5. Okay, drawing a quick sketch of this. I only need my vertex, so this is -2, 5, so right here. And then my y-intercept, so -3 right here. And then I draw my U shape. So now looking at transformations of quadratic functions, we're going to go through each A, B, C, and D to see how it affects the function. So starting with A, what A is going to do is that we are going to multiply all the y values by A. So if A is 2, that means all the y values get multiplied by 2. If A is greater than 1, we have a vertical stretch by A. And if A is less than 1, we have a vertical compression by A. If A is negative, then we have a reflection over the x-axis. Okay. Now looking at B. Okay. B means we multiply all the x values by 1 over B. Remember, reciprocal from absolute value functions. If B is greater than 1, we have a horizontal compression by 1 over B. And if B is less than 1, we have a horizontal stretch by 1 over B. If B is negative, we have a reflection over the y-axis. For C, what I want you guys to do is I want you guys to focus on everything inside of the parentheses when we're talking about C. So if we have x plus C, we're going to the left. If we have x minus C, we're going to the right. And lastly, D value. If we have a positive D value, we're going up. And if we have a negative D value, we're going down. So let's go ahead and see how that works in example 5 and example 6. So in example 5, we're starting off with our parent function, f of x is equal to x squared. And then we're going to do a horizontal compression by 1/4, and then we're going to go 3 to the left. So 2 things are happening here. So let's go ahead and label our A, B, C, and D. A is not being there is no A. Because we don't have anything happening vertically or we don't have anything reflecting over the x-axis. So I'm going to put none. B, we have a horizontal compression by 1/4. And remember, B is always the reciprocal. So that means our B value is if we flip 1/4, we get 4. Our C value is 3 to the left. And remember, when we're going 3 to the left, that's the same as saying x plus 3. And then we don't have a D value. So if we were to take our formula, the y equals A, parentheses B, parentheses x minus C squared plus D. We do not have a y value. Our y value is just a variable. We don't have an A value, so I have y is equal to, leave that one blank, parentheses, our B value is 4, our C value is x plus 3, and we don't have a D value, so that's my answer. Then on number 6, we're doing the same thing, and I'm going to highlight all of my transformations. So I have a reflection across the y-axis. I have a horizontal stretch of 5. I'm going 6 to the right and 2 down. So I'm having 4 things happening here. So I'm going to label my A, B, C, and D. Okay, so nothing is happening with A because I don't have a reflection across the x-axis. With B, I have 2 things happening. I have the reflection across the y-axis, which means I have a negative, and the horizontal stretch of 5, but remember I always take the reciprocal of that. So instead of 5, it's going to be 1/5. So this is 1/5, which means that my B value is -1 times 1/5, which is -1/5. My C value, it says 6 to the right, which I know can be written as x minus 6. And my D value is 2 down, which I know is minus 2. So if I was to write my formula here, I do not have an A value, so Y is equal to parentheses. My B value is -1/5. My C value is x minus 6, and my D value is minus 2. That's my answer. Okay. For number 7 and number 8, we're comparing our parent function, so I'm going to highlight that in pink, with our new function, which I'm highlighting in green. And one easy way to compare them is to compare the vertex of each. So for my parent function, my vertex is always 0, 0. For my new function, my vertex for this one is -3, 4. So we are looking what is happening from the parent function to the new function. So starting with our x's, and remember our x-axis is horizontal, so we're going left or right, we go from 0 to -3, which means we are going left 3. And then our y's, which go up or down, we go from 0 to +4, which means we go up 4. Now we have to look at this graph. So we determined that it went to the left, we determined it went up, but if we look at our new function, it's also flipped upside down. So that means we have a reflection over the x-axis. This right here is our answers when we're describing the transformations. And then on number 8, we have our parent function and our new function. So we are going to write our parent function's vertex, which is always 0, 0, and our new function's vertex, which is 1, -2. So new parent. Okay. Looking at our x values, which determine if we go left or right, we go 0 to 1, which means we are going in the positive direction, so we're going right 1. Then our y values that determine if we're going up or down, we go 0 to -2, which means we are going down 2. Now looking at our parent and new function, notice that they're both going the same direction, so we don't have any reflections here. But the new function got wider. And since the new function got wider, we would describe this as a vertical compression or a horizontal stretch. Remember, these two things mean the same thing. So you don't have to write both every time, you just pick one of them. So you're either describing it as a vertical compression, which gets wider, or a horizontal stretch, which also gets wider. Okay, and lastly, number 9 says describe the transformations from the parent function, graph the transformation equation, and give the domain and range of the new function. Okay, so we are labeling our A, B, C, and D. So our A value here is -1, our B value is 2, our C value is 1, and our D value is 3. Okay. That -1 for our A value means we're going to have a reflection over the x-axis. The B equal to 2, since 2 is bigger than 1, we are going to have a horizontal compression by 1/2, because remember, it's always the reciprocal of that number. Our C value is 1, which means we're going right 1. And our D value is 3, which means we're going up 3. So drawing my parent function, remember this parent function stays the same. This is that y equals x squared. I'm going to pick some negatives, a 0, and some positives. -2, -1, 0, 1, 2. Remember the y values here, just square the x values. So this is 4, 1, 0, 1, 4. Now we look at our a and b values for the transformation. Remember, the a value affects the y. So our a is -1, so we're going to do y times -1. And our b value affects the x's. So our b value is 1/2, so times 1/2. Okay. I am then looking at these x's, multiplying by 1/2 to find my new x's. So I have -1, -0.5, 0, 0.5, 1. Then I'm looking at these y's, multiplying them by -1 to find my new y's. So -4, -1, 0, -1, -4. I am now going to ignore this table. I no longer look at this table, and I'm only looking at this table. For the add and subtract, I look at my C and D values. My C value is going to affect my x's, so I'm going to add 1. And my D value is going to affect the y, so plus 3. So now I'm taking this x value table, adding 1 to it to create my new x value table. So I get 0, 0.5, 1, 1.5, 2. Then I take this y table, add 3 to it to get my new y table. So I have -1, 2, 3, 2, -1. This is the table that I am graphing over here. So I'm going to go ahead and plot those points. So I have 0, -1. I have 0.5, 2. I have 1, 3, 1.5, 2, and 2, -1. Okay. This is my new graph. Notice that it flipped over the x-axis. It got skinnier. It moved up 3 and went right 1. So describing the domain, it's always -infinity to positive infinity. Our vertex here is at 1, 3. Our axis of symmetry is always the x value of the vertex, so x equals 1. And our range, since it's pointing down, is going to start at -infinity and go to the y value of the range, or the y value of the vertex, so 3.